Hi guys, welcome to Olsen Cafe. Sorry to keep you waiting. In this video, I will cover some of the basic features on sine graph and cosine graph, in particular to help you identify the amplitude, the period, and axis of curve. And we will also look at how these three will affect the shapes of the trigographs. Now, to begin with, this is some of the basic graph that you need to know, the basic sine and cosine graph. So what you see in this standard set of the graphs, you will have one complete cycle, right? And that gives you the period as 360 degrees, and the amplitude is also 1. So this is the basic of basics that you need to know before we move on to look at amplitude, axis of curve, and period. Now let us take a look at this, the first graph. All right, so we will see y equals to sine theta and y equals to 2 sine theta. Now we already know the basic sine graph will look like this. Yeah, one complete cycle. So this is the standard sine graph. Now, so you notice the second graph here that we have is y equals to 2 sine theta. Now there is an additional 2 outside of the function 2. So what is the impact of these two here? Right, this will actually affect the amplitude of the sine graph. So when we do a sketch, right, the shape of the graph will get this. So you can actually use a Desmos graph to help you to check the shape of this 2 sine theta. So over here, all right, so this will give you y equals to 2 sine theta as I mentioned, right, it will affect the amplitude. So the highest value here, the amplitude is 2. Yeah, so with this, then we can actually move on to fill in the blank, all right, of the space here. So what we are going to have is this. Let's try to write it down. So over here, the axis of curve, no change. In this case, the axis of curve for these two graphs, they remain as y equals to 0, or is simply the x-axis. Yeah, and by taking a look at the two graphs, in this case for sine theta specifically, right, the highest value of the graph here is 1. And the smallest value of the range here is -1. So in this case, amplitude, standard graph, amplitude is 1. So this will give you the amplitude. All right, so this is 1. And period in this case is one complete cycle. So it is 360 degrees. So on the same note, if you move on to the second graph, y equals to 2 sine theta. So in this case, the axis of curve, all right, there's also no change. There's y equals to 0. And right now, the highest value of the second graph, 2 sine theta, you notice becomes 2. And the smallest value of the graph, y equals to 2 sine theta, it is now -2. So over here, amplitude is 2. And in this case, the period, what we are having here is still one complete cycle. So therefore, the period, it is still 360 degrees. Yep. So that is done for the first type of the graph whereby it affects the amplitude. Now, let's take a look at the other type. So in this case, you notice that the number 2, it is inside of the function sine. So let's see what happened here. Yeah, so we start off with the standard sine graph. So with the number appear inside the function sine, so now this will show me that I will have 2 complete cycles. So we have one cycle of the sine graph, and then I have another cycle, right? So there are 2 complete cycles over here. So you can see one cycle, second cycle. Yep. So this show how the number inside the sine function actually affect the shape of the sine graph. Yep. So with this, again, let us fill in the space. So over here, what I have here, axis of curve, it is still y equals to 0. Yeah. So this is your y equals to 0 here. So that is your reference line. And the original graph, So again, no change. Maximum is 1, minimum is -1, amplitude is 1, and period, it is 360 degrees. Yep, so that is a standard sine graph. But now with y equals to sine 2 theta, so how it will affect the graph. So this is the y equals to 0 for axis of curve. Now, is there any change to the amplitude? You notice that there is still no change. Amplitude is still 1 because the coefficient outside of the function sine 2 theta, it is still 1. Yep. So over here, the maximum value is 1, minimum value is -1, amplitude is 1. Now, what is the amplitude here? You notice that for one complete cycle, it gives you 180 degrees. Yeah, so that is how I can conclude that the period is actually equals to 180 degrees. Yeah? Or some of you, if you take a look at the formula, you will notice that it will shows you 360 degrees divided by the number 2. So that is how it gives you 180 degrees. Now, so far we have only take a look at sine graph. So how about cosine? So perhaps we just take a look at over here. So in this case, we have y equals to cosine theta or cosine graph. And the second graph that you see is 2 cosine theta plus 1. Now let's take a look at the 2, right? The 2 outside of cosine theta. So the basic features of cosine and sine, no change. It's the same, all right? They are similar. So therefore, by now we will know that with the number 2 outside of the cosine function, this will have an impact of the amplitude. So we get the basic graph done. We will have a cosine graph that is with amplitude 2. So this will give me the shape of y equals to 2 cosine theta. Now, how about the plus 1? How will it affect? So this plus 1 is simply, you can take a look at the value of y from the original graph. All right, the original graph is simply add 1. So with this add 1, this plus 1 actually gives you the axis of curve. So I just going to add on this line, y equals to 1 over here. So what you will notice is for every point from the original graph, right, it will actually increase by 1. So say I start off with 2 here, this point, all right, the value of y will increase by 1. So if I take a look at another key point, which is here, so now this point add a 1 will become here. And then the lowest value from -2, if I add 1, it will give me here. And similarly, if I move every single point from here, I move up by 1, this will give me this. And the last point here, which is this, all right. And then when I move, when I add a 1, it will give me this point here. Yeah, so with this, I put them together. This is the shape of the final graph that I have for 2 cosine theta plus 1. Yeah, so over here, let's fill in the blank. So what we have here, as I mentioned already, y equals to 1 is now the axis of curve. Yeah, and how about the maximum value of the range? If we are going to write out the range, you notice that the maximum value now is actually 3. And the smallest value of this new function here, you notice it is -1. So this one is the smallest value. All right, the smallest value of the range. Now, how about the amplitude? So amplitude, you take a look at the number outside the function, in this case, which is 2. So you take a look at where is the amplitude. It is here. All right, we take reference from the axis of curve. So it's a 2 here. So therefore, amplitude is 2. And how about period? So for period, again, you take a look. Now I'm referring from 0 to 2 pi. Since the scale here that I use is in radian mode, is in 2 pi. So within 2 pi, I get one complete cycle. So therefore, I can say that the period for this graph is actually 2 pi. Yeah. So over here, we are talking about the axis of curve, how it actually affects the shape of our cosine graph. Now, let's take a look at one more graph. All right, so this time round, all right, what you see Okay, the maximum and minimum value you can just derive from the range, yeah? Okay. Now, so let's look at the last graph. We have y equals to y minus sine 2 theta. So over here, you notice that there is a negative sign. So to do that, right, we will go by the basic. So basic sine graph that I have, I know I get 2 complete cycle, right, which I have covered earlier on. Now, so what happened is when there is a negative sign in front. So what it simply means is that the whole graph is being reflected. So whatever positive, all right, value, it will reflected along the x-axis, and now you will get the shapes like this. All right, so the positive value now become negative, and negative will become positive, and so on and so forth. So this will be negative y equals to negative sine 2 theta. Now, so you notice that again, there is a 1 here. So that means the whole graph will have to move up by 1. So that is a vertical shift. So when it's moved up by 1, so which means I know that my axis of curve is actually y equals to 1. So I draw this line. So with this, now every point, I'll take a look at the key point of the graph, it will move up by 1. So from, which is, I'm looking at the green graph, yeah. So this one, from here, I move up by 1. So I get this point. Then from this one, the green graph here is a negative 1. I move back by 1. So it will become here. Then every point I move up by 1, move up by 1. So I go through point by point, I move up by 1. So this move up by 1. Every point I move up by, the key point I move up by 1. So the moment I do this, so this green one, I move up by 1. I move up by 1. All right, so when I put all these together, all right, this will be my graph. All right, so this is my graph, y equals to negative sine 2 theta plus 1. So all I need to do is just to rearrange a little bit. Okay, so hopefully you get to see the shape. So the final graph, of course, when you're asked to sketch, right, you actually no need to show the other two. All right, so the other two graph here is just for you to visualize, right, how it works. Okay, so you don't need to have the two graphs. So you just need to show the final graph will do. So let's try to fill in the blank. So over here, I will have y equals to 1. Now take a look at the highest value or the maximum value of this graph here. You notice it is 2. And how about the negative, not negative, the smallest value of the graph here? You notice that the smallest value here is actually 0. Yeah. And how about amplitude? Amplitude in this case, if we take reference from the axis of curve, it is equals to 1. Now, how about amplitude? So amplitude in this case, you have 2 complete cycle. Yeah, 2 complete cycle. And so within 1 complete cycle, I have height. Or we can simply take it as 360, which is 2 pi here. I divided by the number 2. So 2 pi divided by 2, this will give me pi. So with this, I hope it gives you an overview of how the basic features of the sine and cosine graph will affect the amplitude. Yeah, so with this, there is this summary of the triangle graph here that you can see how you can actually work out the maximum and the minimum value, the amplitude and the period as well. What I have not covered is tangent, which I hope to cover in my next video as well. So with these basic features, it will give you a understanding. So, but knowing this is not enough, right? You need to know how to actually sketch the graph on a plain piece of paper. So to do that, you need additional skill, which I hope to cover in my next video. So stay tuned and look out for my next video here. All right, welcome to Olsen Cafe, and thank you for watching this video. And in Olsen Cafe, mathematics made simple. See you guys.